So I'm going to go ahead and get started. I will start off by saying that based on the feedback from the first session I did today, I've made a handful of changes to this set of slides. And specifically, we now have some puppy photos. So this little guy is Quasar. He is 11 weeks old today, and he is available for adoption. For those of you who don't know me, my name is Aaron Gelfand. I've been using LabVIEW since LabVIEW version 5 in 1998. And I am very heavily involved in dog rescue. My wife and I specialize in taking in the dumped pregnant dogs, helping them give birth, which is called whelping. In cats, it's called queening. And in 13 years, we've had just shy of 600 foster dogs either be born in our home or spend at least one night in our home. And per request, here are some of the ones we've had so far this year. On the left was a litter of 10. They were born at the end of December. That was our wicked litter. In the center was a litter of 7. That one was 6 boys, 1 girl. We only had them for 2 weeks. They were supposed to stay with us longer, but then that gal on the right, they originally hadn't known she was pregnant. She turned up pregnant, so they're like, Aaron, can you take her and we'll find someone else for the other puppies, since they're older. So we're like, okay. And so she gave birth to 3. Our giants are female. When we do our giants are female presentations, we frequently talk about the women who have had bigger impacts in the field. But that doesn't always recognize the women who may have a smaller impact on the field, but a bigger impact on us personally. 30 years and 4 days ago, I started a internship at Walt Disney World as a scientific dive intern. 6 months of getting college credit and paid to scuba dive at Disney. It was wonderful. It was also a very transformative experience for me, and that was due to the scientific dive team manager, Marianne Buin. Unfortunately, the only photo I have of her is this one, where she's in the upper left corner with a whole bunch of us. And that entire area where we're all standing now is actually underwater. If you go to Disney's Animal Kingdom and do the Kilimanjaro Safari ride, that area is the steps you'll see as you're driving past the male elephant enclosure. And those are all underwater right now. So let's talk about the data librarian. We've actually heard in a couple of the other presentations people talking about how do you share data between modules, and especially how do you do that without introducing a lot of dependencies between modules. It's not only sharing data between multiple instrument acquisitions, but how do you share your data between your acquisition, your analysis, your logging, your display? A couple of examples I have that I have had to deal with is in one of the projects that I'm maintaining, and I haven't redesigned this portion of it yet. There, you can enable a bake mode for the system, and the bake mode relies on knowing the physical state of a number of the valves. So that's the digital module. It requires knowing a bunch of the pressures, and it actually lives inside the pressure module, but it also requires knowing a bunch of the temperatures at the same time. And so now all of a sudden, the pressure acquisition module, because of the design, is interdependent on both the temperature module and the digital acquisition module. So it gets a little complicated. Likewise, on that same project, there's motor interlocks, and the motor interlocks are based on temperatures, they're based on pressures, they're based on some of the digital signals. And so now all of a sudden we've coupled the motor communication module to all the the temperature module, the pressure module, the digital module, the alarm module, because certain things aren't allowed based on some of the alarm conditions. And so the dependencies get a little bit crazy. Um, and so over the years, I've been looking at how do I get, how do I avoid introducing a lot of these dependencies and come up with a decent way of storing my data, um, and, while providing a mechanism for anybody to know about the data. So a lot of my projects over the last decade have primarily been based around scalar data, individual numerics. Most of my projects, I haven't been worrying about waveform acquisition. I'm not worrying about the high speed acquisition, the RF type of acquisition. It's all just scalar data, voltages, currents, digital signals that are relatively low speed, but also I'm worrying about the current value, not about analyzing a waveform. And so I worked on creating a library to provide scalar data, to support scalar data, to allow me to decouple my data acquisition as an analysis, to allow for both poll or event driven um, acquisition analysis retrieval, and to make the formatting and display easier. So adding metadata to make it easier to use. The implementation was that of a current value table. I had actually forgotten that name until Mike, you mentioned it earlier in your presentation, so I rapidly updated my slides. All of the data is stored under the hood as an extended float. Um, it provides both automatic or manual timestamping, and it supports optional formatting, optional metadata, and optional events that can be evaluated on data update so that we can create an event-driven architecture based on data change, without having modules have to do polling. And so now my motor module or my pressure module or my temperature module or my bake module, once I finally create the bake module, or my alarm module, don't have to know about all the other modules. They just have to know about the data librarian. They need to know what they retrieve from the data librarian, so they do need to know at least naming of what the other modules are going to push into the data librarian, but they don't actually have to know anything about the other module. I have two versions of this that are in my package. The first, the one I use most frequently, is a global based version. All of the data is accessible anywhere in my program. But I also have a second version that's class wire based, so I can have segregated data silos. The basic use on this is fairly straightforward. I have a initialize VI that has an optional input to allow me to register default events on all items that get published to the library. I'll go more into the events later on. I have a set data item. The set data item is a malleable VI to allow it to adjust a couple different data types. But basically, you pass in the name that it's going to be stored under, you pass in the value, whether it's a numeric, a timestamp, or a Boolean, or an enum. I also have a second version of this VI where you provide a timestamp input. This version of the VI automatically timestamps for you under the hood. Get data item, pretty simple. Provide the name you want, you get the value, you get the timestamp. It will both throw an error on error out saying the item doesn't exist and give you the not found Boolean. Future version, I plan on giving a property to allow you to turn on or off whether or not an error is passed out if something's not found, or if it just forces you to look at the not found Boolean. I also have a couple of variations called get data item formatted. The top one will use the optional formatting that you've specified. The bottom one also includes not only the formatting, but appends the unit to the end. These ones are used primarily for display purposes, whereas the get data item, which is giving you the value, is primarily used in line for analysis. There's also a variation called get coerced data item. I use this a lot for enumerated data types because it'll just convert, instead of giving you the extended float, it will allow you to get the enumerated to get the enum value without just dropping a coerced to data type. I also have various versions of get all, which are primarily used for display purposes. There's a get all, which is going to give you all the names. There's a get all plus values, which will give you the names plus the string values. A get all that gives you the names plus the extended numeric float values. And so there's various ways of just pre-built displays for showing off the data. From a more complicated perspective, I have extended use VIs, and so this is where we start using the formatting. So I have a VI called set format, which is a malleable VI, and you can provide it a cluster of a true string and a false string. And so when you do the get formatted, and if the data was just zeros and ones, it will use the false string and true string. You can provide a string input and use regular LabVIEW numeric formats, %G, %F, %E, etc. You can provide an enum, in which case it's going to treat the data under the hood as enumerated values. So if you have a value of 2, you have a value of 4. When you read the string versions back, it is giving you the the values you've given in the enum. So for example, you're seeing here that trolley.position, which is an enumerated value, is in the park value. Trolley.pressure is giving us 9.9 e to the 10. Trolley status alarm, that one's a Boolean, so it's normal or in alarm. And we also can provide a string array, which operates very similarly to providing it an enum. Now, I said this is really designed around scalar data, but the fact that we can change the formatting on the fly also gives us a backdoor way of handling the string data, because I can just keep the item as a data value of 0 and change the string enum on the fly, and if I read it, I get that new string. Units. I have the ability to set units as metadata. When you add units, it's used for display purposes only. It does not, if you give it millivolts on one item and volts on another, it's not going to multiply the millivolts or divide millivolts by 1,000 if I'm also comparing it to the volt one that has volts. It is display purposes only for metadata. I also have the ability to get or set metadata. This is class-based, where you can give it a metadata class. I added this in, but I never ended up using it, but it still exists. Now, I mentioned that I wanted event-driven. And so what I've done is I provided an event API. We saw that our initialize allowed an event class or an array of event classes to be automatically added to all items, but I also have the ability to, on an individual item, add an event, giving it I give it the name of the item in the library that's getting an event. I give it the event name, and I give it the event class. I can get the events. I can remove an individual event. I can remove all events. And the remove and remove all also allow removal of default events. And I'll talk about why that can be quite, removing the defaults can be quite beneficial. So we can, as I said, we can optionally add a common event to all data items. So one event that I might add to everything would be a event for like on change that triggers my data logger so that my data logger gets all notifications of value changes. But maybe there's certain items I don't want to log. For example, CPU utilization might be considered noise in my data log. And so it's easier to just add the logger event to everything and remove it from one or two items versus adding it to 90% of my items individually. So the actual VIs, fairly straightforward: data item name, event. I require the event name so that we can remove them as needed. And this is class based. So I have an abstract class. When I wrote this, it predates interfaces. And so the abstract VI has a single required override, no optional overrides, and the required override is called the changed event. You pass in the data item name, you pass in new value, last value, and timestamp, and you can do anything you want with this data. Some of the included events that I ship are on update, which triggers an event whenever a value is written to the data item. So even if we wrote the same value and it isn't different, we'll trigger this event as an on update. I have an on change event, which triggers if the new value is different from the old value. I have an on threshold change where we can trigger the event if the new value is different by X amount from the last updated value. So these are three global reference classes that I ship as that I include with my reuse library. By calling them global references, when I call the VI that generates the event class, it has a first call and will always return the same reference. Whereas on some of my for some projects, I also want the same version that gives me a different reference each time. But again, it's a very simple class to create. So if we look at an example of this, I have my on threshold change event. And the on threshold change event looks at our last updated value. It subtracts it from our new value, or our new we subtract our last value from our new value. We take the absolute value of that, and is it greater than our threshold for change? Yes. Update the last updated value and trigger an event for anybody who is monitoring for events. So an example is creating a data logger. I have the log event, which is my create the reference, and anytime any data item changes, because I had also used this VI and passed there's another output to my initialize, I will automatically trigger the log event and log a new data item. Other event cases that I'm using in current projects are position status. What is the position? Well, different types of positions are analyzed differently. Some positions use one Boolean data item. Some positions use two Boolean data items. So if either one of them changes, I need to reevaluate what position I'm in. Another position is five Booleans, which is five Boolean inputs, five digital inputs, that is also modified by whether a sixth output is on or off, because one of the digital inputs is invalid if that output is off. And so in this case, I have a position daemon where I register only a handful of the data items to trigger. If the data item name changes, I trigger my evaluation of the position evaluation, which is class-based because I have a couple of different types of position evaluations. And so under the hood, it calls that position evaluation and sets the name of the combinatorial position output. And if we look under the hood of some of the classes, I have one class that can be, you can configure the position sensors. Some of the position sensors are just on off single channel. Others of the position sensors, I have an open signal plus a closed signal, which means I actually could be open, closed, both or neither. Um, both is considered error and is what we see here in the right hand corner, um, or neither is considered unknown because that indicates our valve is traversing between the two positions. Likewise, the system has two e-stops, so when I'm evaluating if the system needs to be paused, then I just read both of those and say, hey, one of the two of them changed, check both of them. If either one of them is off, I need to put the system in a paused state. What does this look like under the hood? The global version just has a map. It has a DVR of a map. So I'm storing the data value reference so that I'm looking in and out of the map when a item changes. When a user calls set value, I convert the data type, I validate the name, I look my in my map. If the item is in the map and if the item is not in the map and is being called for the first time, I will add the default events to it. After that, I set the value, in which the set value is just changing some parent class data, and then I run any events which might be registered for this particular object. Any given data item can have no events. It could have 10 or 20 events, depending upon who cares about being notified when it changes. Are there any questions so far? Chat's been relatively quiet. Okay. Because this is a current value table implementation, it is based on what is the current state of the system at any given time. It doesn't care about history. So I have an expansion module called my data historian, and the data historian will register for the events, and it creates an XY data set. And I also allow for metadata such as scale, because generally if I'm using the data historian, it's because people want to see everything on a graph. So this supports XY graphing as well as I provide metadata to include information for scale and such. An example of the historian is I'll initialize the historian. One of the fields of the data historian is the data historian length. I will automatically, to prevent memory from growing uncontrollably, you initialize it to say, I want 6 hours of data, I want 3 hours of data, I want 2 days of data. We then initialize our data librarian, we give it our on update event, and this top loop, I'm just generating random numbers, and then I register for the events, and on the update event, I update the value into the historian's memory space, and then if it has changed, I will go ahead and graph my data. This example is also showing, I'll look at, because this is a example for debug purposes, I also show what's my total size, how many items do I have in the historian right now, and how many of each item do I have in the historian. Historian example, the front panel just shows graph data. I can change how fast I'm updating. And so for the example, I only have the one item, and at the point I took this, it had 368 samples of data. So I had more slides on this one than my previous presentation, but I actually ran through them a lot quicker than expected. Well, Mike, part of why I'm presenting this is to figure out if people want this, in which case I do. If I get good feedback, then I do plan on releasing the two of these later this year. I wasn't sure how much people would be interested in it, so that's one of the reasons I did these presentations. This is how I solved my problem. Is this going to be useful for other people? Unlike unlike the data value engine, the data variable engine, which does need some extensive rework before I consider it releasable, this one is needs some documentation, and that's about it prior to release. Michael, I have not had an event structure getting overload. I have not yet had an event structure getting overloaded that was not the result of a bug elsewhere in the code. I have overloaded it. And the way I overloaded it was my co-developer had a mistake in one of their calculations that ended up mass triggering the event structure with a timeout of 0, and it would run away, and then it would reanalyze and say, oh no, it was supposed to be 750 after I've just triggered it like 1,000 times. And this was in a parallelized module that we would be launching dozens of these. And so, yes, it is possible to overload it, but we were overloading it because of bugs in the event structures that were generating data. Answering Darren, have I used the NICVT library? Yes. I used it years and years ago, and I will admit that some of its concepts provided inspiration for this, but I had not used it when I designed this. But I had used it previously, and some of its ideas inspired some of what I was doing with this one. I cannot tell you how its last set of APIs corresponded to I can't tell you what its API and set of functionality corresponds to mine more recently. I don't think it had event support, and also it was as I recall, it was designed around it supported, I want to say, 4 different um, data types, where it had an internal memory space for booleans, it had a second internal memory space for strings, a third internal memory space for ints, and like a fourth internal memory space for floats, if I recall correctly, whereas I took a generic approach. Michael, I want to say, Michael, I think the last time I looked, it might have changed, but I think it used global arrays under the hood of the 4 different data types, because if I recall correctly, for higher speed performance, when you inserted an item into that CVT, it could give you an index of where it existed in the array, and you could use that for higher speed access. Now, it also drastically predates maps, and so I went with the approach of using named lookups with maps, with the map. I have sort of considered whether I want to switch to two different maps, where one map has the numeric has the numeric value uh, the last value, the timestamp, and the second map has the metadata because it's accessed less frequently. But other than when we found bugs in other pieces of my code, it hasn't been a performance issue for me, so it hasn't been worth redoing the under the hood. Now, there was also a wrapper around the CVT um, library that added network communication for the CVT. So you can transfer the CVT back and forth across the network. If you ever try using that, it ends up that if you don't preset the names, I want to say it was the names of the items correctly, because the network version did require you use naming rather than the integer indices. Um, then the if you got them out of sync, you would get a bunch of error messages, and I probably spent 8 hours debugging one time to figure out, oh hey, there was a mismatch in the naming on the two sides, because the error message was just that poor. And then I did um, and then I did I put that I had it working, put it away, came back on that project like half a year later and made the same mistake and had to spend the same. Oh, I didn't spend this entire 8 hours debugging to find it. I only spent like 5 this time, and then I'm like, oh dang it, I remember this. Derek, I haven't run it. I know that in theory a single global CVT can cause contention. It hasn't been an issue with my projects, so I haven't tried to figure out how many CVTs to subdivide it into for better access. Yeah, that would be a different use case. The systems I'm using this on right now are maybe two, one Cerio, maybe two, maybe a Cerio with an expansion chassis, um, and so that's a lot different than 15 PXI systems that are like 18 slots. Definitely a different use case. How do you generally decide which CVT to use, or how many CVTs? Based on different data types, or so source? Okay. And I could see that would end up adding a bit more in terms of the dynamic of having to, at that point, conceptually, although it would defeat the purpose, it's almost a map of maps at that point. Just in terms of oh, it's this source versus this source versus this source. But I implementing, yeah, I want to do it as a map of maps, because that would defeat the purpose that you're suggesting. But conceptually, I could see doing that. I could also just see I could see it as doing a malleable VI that you provide an enum of saying um, which submap you put it in. So Michael asks, is there a reason not to set up all events on creation? If you don't subscribe, who cares? Um, I provided the two different ways of doing it because I wanted options to provide more flexibility. My my data logger wants to subscribe to most things, but things like I don't want to be logging CPU. I don't want to be logging memory to disk. It's noise, and so having the ability to globally add and then remove one or two items is good because I had played with a different version in which the logger has to know, oh, hey, if it's this name, don't log it. If it's this name, don't log it. If it's this name, don't log it. And to me, that seems like having a whole bunch of event structures that are having to filter, oh, I don't really care about this. Oh, I don't really care about this, makes less sense than being able to than most event structures being able to say, I just want to register for this specific data item. And so I provide, you can go with the way I have the API designed, you can do both ways, neither way or one of the ways. And I do have the API that like will give me the list of all of the items. I don't I've implemented it externally, but I haven't incorporated it into the library to give me like a filtered match of saying, hey, give me all the ones that match this pattern. I've done that. I've done a little bit of that externally, but not internally into it. Um, Let me bring up. Give me 1 second and show. Um, and other VM. Do I already have? Okay. Do I have LabVIEW open? Yes, but I did not. No. So if I bring up, give me 1 second here, having to reallocate. So what I could do is I have. Oops, don't need to do my initialize. So events. So this is the on change event. This is the on update event. So I can set everything gets the on change event, for example. Then I could set a specific item. What? Oh, wrong VI. Unfortunately, one thing I've learned, and I don't quite know how to fix this, is that I have the VIs because they're in two different libraries, but they're named the same, and for whatever reason, um, I always get the one that's class-based rather than the one that's global-based, even though I generally want the one that's global-based. But it's entirely possible for me to do something along these lines where I do something like this. And so this event structure will be triggered for everything. Whereas, and I actually have this backwards. Um, do that, where I can have one event structure triggering on everything. Oh, it looks, darn it, it started sharing the when I closed the presentation, it started sharing the wrong screen. Let's fix that. My apologies. My apologies for that. But yeah, when I took PowerPoint out of presentation mode, it had screwed up my monitors, and I had to move one thing over, and I didn't realize that it also screwed up the which screen was being shared. My apologies. Anyhow, I can set up multiple loops that get different events based on what they need. But this way, like if this top one is my data logger, and it's doing on an update event, I'll get the data item name, I'll get the value and timestamp, but if I don't want certain information going into my logger, for example, then I have to have this case structure that keeps evaluating, does is this one of the cases I'm not supposed to log, or is this one of the cases I'm supposed to log? And so it, having the ability to do both a global event that everything gets versus things that only specific things get, to me, unless I misunderstand some of the low level things behind how event structures work, means I'm getting less overall CPU utilization because I'm not having all of my loops filtering all of these nonsense events that they don't care about based on the data name. If that makes sense for everybody. If I bring up the C-Rio code, which will actually take a little while, unfortunately, decent sized project. Not as massive as some of the ones that I know this audience has created, but decent sized nonetheless. It'll take a little while to load, but I can show where I have multiple different loops doing different things that only care about 4 or 5 of the data items, so they only register for the ones they care about. So there's the position loop, which had been inside some of my slides. There's the data logger, which cares about practically everything. There's the I'm using the NISTM toolkit, and so there's a I have an event so that anytime something changes, if I'm connected to the host computer, I'm transmitting that change. But there's also smaller um, events that there's other loops that handle certain interlocks in certain modes that only care about a handful of the data items under the hood. If we look at this this data view, I can show this is all of the items in my library. We do have an alarm on the system right now. One of my motors isn't home. It looks like we probably. Oh, I had disconnected the motors. Yeah, I had disconnected the motors, so that's why we're seeing like the steps being maxed out right there. But I have I have let me see just the temperatures, and we can see I'm talking to my temperature simulator, and I'm getting the interlock not met message. And again, that the interlock not met is formatting positions. Again, this is going the positioning is based on digital signals. It looks like my growth cryo rough valve position is in the wrong state. Let me find where is growth cryo rough. Growth rough one opened, and there we are. So if I can do this without unplugging it by accident this time. So this system here, I designed my own interposer boards. So I have one C Rio that has a bunch of that has uh, two digital input cards and two digital output cards that acts as a hardware simulator for my customer system, talking to their C-Rio, um, which has two digital inputs, two digital outputs, 64 channels, and I created an interposer board that allows me to either do a pass through, force on, or force off, and you can see the LEDs turning on and off as I do that. So I can force both the inputs and the outputs um, to give different information. So now that that has finished opening, let's open up RT main. And again, that'll take a little while to load. And so like there's this motor helper um, that registers for it only registers for the jog inputs. There's a digital input for jog forward, a digital input for jog reverse, and there's some enabling. But so I'm only looking for the jog forward, the jog reverse, and the pause, because if someone hits the e-stop, I need to stop the motors immediately. So here you can see where I create a on in this case I'm creating an on change reference that only this event handler will ever see. The other event handler structures don't register for this specific event. And so I add it to the pause signal, the jog forward signal, the jog reverse signal, and that's my motor helper. My logger is registered for everything, and that's the one that this is the one I had shown in the screenshots. Um, there's one of my interlock daemons, and again I register for, in this case there's a handful of items that I'll register for. Actually, that's in this one, where I determine which of my channels I need to worry about for different interlocks. So digitally, I have a compressed dry air signal, a nitrogen signal, a water flow control power. There's also and those ones are Boolean on off. I also have pressure interlocks where I'm reading pressures from various things. There's this laser positioning sensor, and so I register for all of those. And so that gets just the input change event, which is it's changed. One of those items has changed, reevaluate its interlock. Um, then there's light pole logic. There's a 5-channel light pole system. So again, I look at, in this case, I look at 3 internal data items, plus I also have to look at the alarm list. And the alarm list is a different module that is not event driven, so I do have to pull in this case, but I have a combination of pull plus timeout to look at the combination to turn my light pole into different modes. And so my light pole can indicate normal operation in semi-auto mode, normal operation in adjustment mode, bake mode, engineer mode, or alarm. Thank you all for your time. I do see that I am out of time. So having the slides finish early was great because there was some great discussion. So thank you all very much. It does sound like there is enough interest that it's worth me going ahead, getting some documentation, um, adding a description to the public-facing interface VIs, because only about 5%, maybe 10% of them have a description, and publicly releasing this. Again, thank you everyone for your time.